10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft.
This Houston, contact with a test 1.
Touchdown confirmed.
Liftoff. Welcome, everyone. Welcome to Space Cowboys, the first episode. This is a podcast about the exploration and settlement of our cosmic backyard and beyond, brought to you from Amsterdam by your hosts, Herbert Blankenstein. Hello.
Hi there, Thijs.
Hi. And myself, Thijs Roos. And we have very special guests today. Herbert, would you like to introduce them?
Yeah, shouldn't we first introduce ourselves?
Oh, that'd be a good idea.
Right, because people need to know who the hosts are, don't
Yes,
they?
especially for a first episode.
So tell me about yourself, please.
Well, my name is Thijs Roos. I'm a science journalist and I have lived and worked in the United States for a while.
I can hear that.
Yeah, people tend to hear it. And now I'm back in Amsterdam and I've had a love for space for a very long time, but I wasn't interested, I wasn't diving into it until about 5 years ago, and it never left me. And this is just a wonderful opportunity to do this with you.
Right.
And I really love it. And I'm so looking forward to all the episodes that we're going to make.
So am I.
Yep.
Okay, my name is Herbert and I'm a physicist by education. And I've been a science journalist since about 1982. That's how old I am.
That's the year I was born.
Oh, right. Okay, that's a fine coincidence then. I've done a lot of writing. I've done TV, radio, and a lot of web stuff, writing for websites, podcasting as well. I do a couple more podcasts here at BNR News Radio. So that's me, and let's look at our guests now.
Yeah, wonderful. And I think over the next few episodes, people will know us better and better.
Oh, I suppose. Yeah, sure. So I think our most important guest today is Rudolf le Poole, who is an astronomer from Leiden University. Welcome.
Thanks,
and you're
Scott.
specialized in scientific instruments on board astronomical spacecraft, right?
Spacecraft and ground-based telescopes. Basically,
Yeah.
astronomical instrumentation is what I've spent a significant fraction of my professional life on.
Right,
And
okay.
I've been busy with space from the very early time. I was a member of the Ranger evaluation team for lunar missions in the mid-60s. And
Wow.
I've been busy with space ever since.
Okay, good. We'll talk with you a lot more in the coming hour in this
That's
episode. Okay, next up is Yuri Nortier.
Yes, hi.
And were you by any chance named after the famous Russian cosmonaut?
No, unfortunately not.
That's
it's not a
too
cosmic
bad.
coincidence. No,
bad.
it's not. No, I was named after a Russian pianist. He died a few days before I was born.
Rudolf likes that.
And a Russian still. But
Still a Russian,
Yes.
so there's at least a bit of connection to the space industry. But no, not Yuri Gagarin.
Okay, well, great anyway. And what we'll be talking about, well, Thijs, would you explain to us the subject matter of today?
Yes, well, today we're going to talk about New Horizons. I mean, it's all over the news right now.
Yes.
But of course, it's been going to its new destination ever since it flew past Pluto in 2000. This was already 16, 15? When did it fly past Pluto?
That was 2015, right?
2015.
Yeah.
2014, actually.
Yeah.
2014?
Yeah, July 14th, 2014, I think. Yeah.
Oh, here's our space.
Yeah.
Oh, wow.
So it's already quite a long time ago.
We forgot to let you explain about your interest in space.
Yeah, it just popped up 10 years ago. I was studying urban planning back then, so there's no correlation with space whatsoever. But I always had this latent interest in
Suddenly you
space.
saw the light.
And suddenly, I think it was due to the fact that in 2007, we had 50 years of space exploration, and that just caught my attention. And then I dove into spaceflight in general, and just everything interested me then.
Yeah.
Okay, so New Horizons it will be
Yes,
in this
yes.
episode, but also...
And I have a new rule for myself. the fact checker, and I'm sorry, Yuri, because you're the head of BNR Digital as well. So we're sort of like guests in your studio in a way. But it was 2015.
It was
2015.
Oh, okay,
yes,
good,
July
good,
14th, 2015.
Okay, let's.
And we're gonna talk about it. And I'm really wondering that maybe during this episode we will get like a new picture of Ultima Thule, the object that New Horizons flew past.
Maybe
I saw
a
one
bit early for that.
It's a bit early, but I saw one blurry picture, and then maybe if people listen to this,
it was blurry, all right.
Yeah, it was blurry, right?
Well,
in a couple of weeks.
Not what I would call blurry. It was a true, very definitive demonstration of a bimodal object,
Okay.
a double-blobbed object, and there was some 15 or so pixels across.
Which is
That's right. Yes.
It's actually amazing. Sorry for insulting the
You
picture.
can't have too many pixels.
No, absolutely. But before we continue and to talk to you both about what New Horizons did and where it might even be going next.
Yeah.
I'd like to just a quick shout out to our sponsor, which is going to be you, the listener. You can support us on Patreon. If you go to patreon.com/Space Cowboys, or the link in the description of this podcast.
Show notes, yeah.
Yeah, you can choose any amount on Patreon to donate. It's a really great subscription model. You decide how much you want to support us, and that's what helps to keep this show going. So please sign up through the link in the description and help us out for the next... who knows? Years, decades of this podcast.
Century, why not? Okay, and we have a Twitter account as well.
Mm-hmm.
It's @Space Cowboys Pod.
Yeah.
So go there for the latest news and any links that we might find handy to send to you.
Turns out there were quite a few Space Cowboys out there already.
We
just joined
the club. We already have
Yes.
some followers. That's right. We're on the BNR website as well, bnr.nl/Space Cowboys. And we have a YouTube channel. Just type into the search window in YouTube Space Cowboys podcast and you'll find us.
Yeah.
And we're recording this very episode on video.
Yeah.
So it will be up, maybe in a couple of days.
Yeah, definitely.
Anytime now. Well, content-wise, we're talking about New Horizons and Ultima Thule. And also we'll probably be talking about the Voyager 2. Because there's a connection, and we may also be talking about Bennu, the asteroid that NASA has sent a spacecraft to, and the Japanese mission that I keep forgetting the name of, but Yuri, you know that.
Yeah, it's Hayabusa.
Hayabusa, that's right, that's him.
Wow. So first, New Horizons.
That's right.
Ultima Thule.
What I'd like to know, and I'd like to ask each and every one of you, how did you feel about the event of New Year's Day? The flyby.
I thought it was okay. The honest answer is I have to think back of when Pluto when it flew past Pluto, and for me personally, that was the first time in my life that I could see one of these objects in our solar system coming closer and closer and closer. And I think maybe, Rudolf, you have experienced this multiple times in your life where you just see this object coming closer and
never seen
it before.
There.
Yes, and I'm sort of still waiting for that. I like media events and I like people cheering, and I think it's a wonderful, sign of togetherness. But I'm personally really waiting for those high-res pictures.
Okay, Rudolf le Poole, how did you feel?
It was absolutely exciting. It is absolutely fascinating to realize what can be done in mind. This thing flies fast. It flies by its own distance from the planet in about 200 seconds.
200 seconds.
So the total event is 1,000 seconds, basically, for the measurements. So it's a very small fraction of an hour, and that does the whole thing, and that generates a pile of data that you can't possibly transmit here anymore in the same time. So that's not live. That comes down in the coming weeks, in fact, in the coming month.
Yes, I believe even
beyond the end of
2
the year.
years or something.
But how big is this pile of data in gigabytes? Do we know?
I believe it. Do you know? Rudolf?
No, I don't know. I didn't check it, but I guess it's of the order of
it should
a bit
be
more than a gigabyte.
8 gigabytes, I'm told. Yuri?
Yeah, but it's more like the upload speed is very slow. I think it's 1 kilobyte per second or something.
Yeah, that's right.
I think
It's
that's
1K.
So that's
I think that is colossal. If I look at that,
You've seen worse, right, Rudolf?
It's a miracle and it's very slow.
very significantly worse. In fact, I saw the very first time you saw a planet come close by, the Mariner spacecraft making pictures of Mars, and their 32 squared pixel image took half a day to come back at that time, and I was only 8 bits deep.
32 pixels by 32 pixels.
Yes.
What's that? Is one bit per minute or something?
Well, it's a bit better than that, but
Okay, we'll do the calculations later.
something like that. But it's because of all the double checks and well, I can't think of the proper word, but it had to be double checked sufficiently before that turned into a proper image. So the images came at a rate of a bit more than one a day.
Right. But the question was, how impressed were you?
Oh, right. And that was absolutely colossally impressive. Looking at the data that we saw coming from Pluto, of course, is already absolutely intriguing and fascinating. And they took a bit more than a few hours for the pass by. And it was at a longer distance, 3.5 times as far away. But in such a short time, getting so much extremely high quality data is absolutely fascinating, and then making sure that we get it all back here. Mind you, the whole message takes 6 and a bit hours to come back here.
Yeah.
And so the first image that we saw was a part of that trajectory between there and here, was sitting as electromagnetic waves coming this way.
Yeah.
And it's fascinating that we can do that, and the quality of data is as if it is just nearby, near the moon or something.
Yeah,
it's absolutely
because how far away is the Kuiper Belt object that was just visited yesterday?
It's about 6 billion kilometers. It's about 40 and a bit more times the distance that we are away from the sun. So
astronomical units.
Astronomical units.
Yeah,
yes.
yeah. Okay, Yuri, how impressed were you by the events of New Year's Day?
I think I was a bit unimpressed.
Unimpressed?
That was mainly because I was
legal.
expecting another, as you, Thijs, already said, I was expecting a bit of a Pluto moment when you see that Kuiper Belt object emerging from the distance, from the blackness of space, and then getting the first high-res pictures, seeing a new world. That didn't happen. I just saw this blurry picture of something that looks quite a bit like a bowling pin or something.
Our generation is so hard to please.
I think we're very
spoiled. We're so jaded. And
we're so spoiled.
Yeah. But how did you feel about it? Because since you're asking,
I had the same emotion as Yuri.
Okay.
I was a bit disappointed because the picture they published the other day was, according to me, it was shot on the way towards Ultima Thule. It was not a flyby picture, because then it would have been higher resolution.
Yeah. Sure. Yeah.
So to publish that the day after, that was a bit of a disappointment to me.
Yeah, yeah. Well, I'm gonna instantly check if they got a new picture already. No.
Yeah. Why don't you do that?
No, not yet. No.
And I was also a bit pissed when I saw the news on the Ultima Thule blog at the Johns Hopkins University's website, because it had, I think, 3 paragraphs of congratulations and more of that kind of stuff.
And the
and
president
only
is
in the
very
4th
proud.
paragraph they came with a couple of facts, and these weren't even very new.
Yeah.
So I'm really hoping for high-res pictures that show us really new stuff.
I'm sure that we're all going to be very impressed. We're going to be so impressed in the next few days. It's one of those lessons of space, right? Space exploration. It's so much slower. Like, we are so used to instant communication and everything now, and if this is trickling down at 1 kilobyte a second.
There's one specific point that should have turned us on a bit more about the excitement that this generates. The fact that we know the whereabouts of this thing to such a quality that we can actually send this spacecraft there is not trivial.
That's incredible.
It
is true.
Positively incredible. And in fact, they did ephemera work to make sure that they would know the trajectory of this thing across the sky in such a way that they could see obscurations in front of stars.
Yeah.
That happened about 3 years ago, almost 4 years, no, 3 years ago, 2 years ago. And mind you, the calculation said that they would then have to observe an obscuration of something that would last 2 seconds.
Mm-hmm.
So this thing would go across the beam between that star and us.
And block out the star's
And block
light.
out the star's light. And
That's how they found it. That's how they found this
No,
object.
that's how they specified the precision of the orbit, so that they would dare fly as close as 3,000 kilometers.
2 seconds in front of a star.
Yes, and in fact, that very experiment, which was 5 times successful, mind you, with small telescopes all over the place in the world, in South Africa and in Latin America, they had to set it up in foul weather, sometimes in weird conditions, because the path had been pre-calculated with the aid of astrometry from the Hubble Space Telescope. And they succeeded 5 of these locations to actually observe it properly. And that gave us the multiplicity of the object already known at that time.
Yeah, wow. And they didn't just find out about the trajectory of Ultima Thule, but also the shape.
That's what I'm saying. It was double. It was observed to be double at that occasion.
They knew that 2 years ago.
Correct.
Really?
Yes.
Yeah.
Well, so space travel is amazing. It's
actually
insane.
what they're doing now with the pictures is checking what they found before.
In a way, but it will go well beyond that. It will, we get pictures of the quality of the Rosetta comet almost.
But now what I also, because
not the later ones, but
but what I also heard is that so how they're taking these pictures, this object is basically the size of, let's say, a big city, right? It's like 15 kilometers by 30.
Yep.
For Americans, that's 10 miles by 20 miles. But the spacecraft is at a distance, what did I hear? Say LA to Washington, D.C. So there's like the entire United States.
3,500 kilometers.
So you're looking at a city from 4,000 a continent away.
Yeah.
And so they have do they have just a telescope, or how does this work?
They have a telescope which is a pretty nicely sized telescope of 20 centimeters diameter. And thereby they can therefore have a resolution which is as good as basically any very good ground-based telescope looking through the atmosphere. The atmosphere messes it up at about that level. Yeah. So it's as sharp as telescope pictures that we can make from the ground.
Something like the full moon or something that you would see from Earth. So
we see on the full moon with a good telescope, we see about 3,000 pixels across.
Okay, yeah.
And that is what we can do also in this case.
So 1 pixel is going to be how many real meters?
A couple hundred.
Couple of 100 meters. Yeah, a couple 100 meters for every pixel.
Yeah,
exactly.
Yeah. Wow. Yeah, I mean, it's still
less
super
than
cool.
that even.
I mean,
it's,
outer space is mostly empty.
It's going to be different from putting a lander on the surface.
Mm-hmm.
Okay, so we'll have the resolution will be lots worse than that.
Yeah.
Evidently.
Yeah.
Well,
but
putting a lander is at 15 kilometers per second, not a trivial matter.
No.
But what do we want to know from this object?
Whatever we can try and figure out. We want to get its mass, if we could be lucky. We want its size, but that we sort of had already from the ground-based observations. We want to get the composition, which we can get from spectrometry. We want to get the topography, and in particular it would be very interesting to see how pitted the surface is, because it has lived its whole life that far away, since it ever was formed.
In deep freeze and everything.
In a deep freeze.
Yeah.
What do you mean?
In deep freeze.
It's very cold there.
It should be conserved.
No.
You know, not only temperature-wise, but also there should be a lot less meteorites and everything
that's the point
in that region. So it should be a lot more polished, so to speak, than an asteroid between Mars and Jupiter.
Wow.
And the history of that bombardment and the component of that bombardment as a part of the formation process at that time, we might possibly be able to infer to some extent from the texture of the surface.
Yeah, and we're talking about an object that formed 4.5 billion years ago, right around the same time as the Earth, the start of our solar system, basically.
Correct.
Yeah.
So it's basically a relic from ancient times.
Yes, it is a relic of the formation history of the sun. The sun comes from a big gas cloud that it gets compactor and compactor, and in doing so, it starts spinning up. It then leaves a plane of gas and dust, and that the amount of dust is so much that the plane itself gets cold at a serious distance from the sun. The sun itself gets warmer and warmer until such time that it ignites its fusion process. But in this cold disk, we can form coagulations of dust, and that will finally make pebbles, and those pebbles will grow into minor objects, and those minor objects can also grow into bigger planets.
Yeah. And is it then, so if it's minor pebbles, right, in this case, is this a pebble, or is this maybe a collection of
This is a collection of pebbles.
Collection of pebbles. So over time, gravity will still eventually
sometimes
just
make these things grow until such time that the density of these pebbles and the smaller particles at such a place has been removed. Gas has been removed in the meantime. That's why it's now looking at the sun, but at the formation time it wasn't looking at the sun. It was sitting in the shade of all this gas between the object and the sun.
Yeah.
So would a comparison between whatever we find at Ultima Thule and, on the other hand, asteroids, would that be relevant?
It certainly is relevant. Asteroids are generally formed much closer in, and therefore were formed in a much more vigorous environment.
Yeah. Hotter, more rocky stuff flying around.
That's right.
Yeah.
And of course, the asteroids are very often built up to bigger bodies. And those bodies collide amongst themselves and have broken up again. And so there's much more dust generated from this milling process that the asteroid belt is doing. And that does not happen in the Kuiper belt. The Kuiper belt is too spacious, too open and too large for these particles to actually hit one another now.
Yeah. I wondered when New Horizons was launched, was 2006, right?
Yeah.
Ultima Thule wasn't even discovered.
Correct.
Okay,
in fact,
so
it's a byproduct of this urge to try and find some new thing to do.
Yeah. Where can we go next after Pluto?
Exactly.
Okay, so after Pluto they went looking, and they found not one but even two, maybe three objects that were a candidate to do this.
Or potential candidates, sure.
So that got me thinking: how many of these Kuiper belt objects could there be? Must be an enormous amount.
Thousands, most likely hundreds of thousands.
Yeah.
But whether they're all this size, that is not so clear yet. We don't have a good feel for the size distribution of these things yet. The very first one was detected by Jane Liu about 20 years ago.
Yeah, must have been a big sensation back then.
At that time it was fascinating, and particularly understanding that there was a thing flying around there at such a distance with that sort of a size was rather unexpected. Not quite, but we had to bring up earlier comments from Jared Kuiper about how the solar system had formed to sort of interpret that. And in fact, that was the onset of the discovery of the Kuiper belt as a real thing that we...
Yeah.
So he just theorized it, and this discovery back then 20 years ago confirmed it.
Yeah, that backed up the model, the general structure of the model that Kuiper had at that time. And it also triggered search for similar objects, which took, 1 or 2 a year in the first few years after Jane found his first thing. But the searches quickly established much and much more, of course, as a byproduct of the worry that we started having around the same time about impacting asteroids on Earth, because that is bad for mankind, possibly.
Yeah.
So sometimes people think that, or I've read that this might be the oldest object that we've ever seen. We don't know yet because we don't have the data yet. But so can it be possible that an asteroid just gets flung in towards us and that it's older? Or is it because we're so far away that people think that it's going to be the oldest object?
It is part of the very onset of the formation of the sun. It's in those few tens of millions or just 100 million years or so that process took place.
And these objects stay there. They never venture into the...
They were part of a properly circular orbiting gas with a low temperature. And therefore, it was basically circular orbits the gas particles were doing. And they just developed there. And once they're big enough, and there's not enough gas left, then nothing pushes them unless...
And there's no Jupiter.
The gravity, that's right. Jupiter is too far away.
Yeah, to pull them into
and to disturb their orbits
in a solar
in a
system.
significant way. Exactly.
Very different from comets, which fly in and out of the solar system.
Yeah.
Sort of.
Well, sort of.
Please explain this all to me.
Comets are at even a further distance than these objects. Comets sit in a reservoir. Well, that's not a proper statement, but they live their life basically at a distance which is of the order of 10,000 to 50,000 astronomical units away from the sun.
Far.
So it's basically interstellar distance, almost interstellar distances. A small fraction of the distance to the nearest star.
So you have the solar system all the way to Pluto. Then you have the Kuiper belt. That's how far away?
That is up till about 200 astronomical units or so.
Okay.
And then beyond that, there's even sparser again. There are tens of thousands, or most likely hundreds of thousands of comets again. And those comets, accidentally, they have a very elongated orbit, coming close to the sun and going away again. But that coming close to the sun, if that is 10 astronomical units, it's still pretty cold there, and so they don't heat up, and therefore you don't see them because they're small too.
Right. Yeah.
If accidentally the orbit gets disturbed in such a way that they can make it to very close by the sun, then they heat up. And then heating up with the thing that has ice in there and so on, they start blowing steam and dust and so on. And that generates comets. That makes these nice tails.
Yeah,
exactly.
Okay, getting back to New Horizons and Ultima Thule. Will there be similarities between this Kuiper belt object and Pluto? Or are these totally different things?
Well, we expect Pluto to have been formed out of not one, but umpteen of these things.
Probably millions.
Falling together.
Yeah.
And in that sense, Pluto has an internal heat source, which is actually sufficiently significant to heat up the local ice there, which is not the ice that we know of, but it's frozen nitrogen. In that case, that gets heated up to the point that it actually made a significant fraction of the large part. There was a part of the order of 20% or so of the visible surface, 10-20% of the visible surface on Pluto, which was basically uncratered. It was very smooth and flat.
Yeah, so you have all kinds of geological phenomena.
Exactly, because the heat flow from the inside out actually does something with the matter and makes that move around. And so that surface is basically relatively young as compared to the object as a whole.
Yeah.
Whereas Ultima Thule doesn't have such a heat source, so that surface gets only modified and eroded by the environment, which is completely different from the case of Pluto.
So it should be a lot more virgin than Pluto.
Yeah.
Do we expect it to be red as well? Just like Pluto turned out to be red?
There's places to be red. They have a spectrometer in there.
It's been measured to be red, right?
Yeah.
It's been measured to be red.
Reddish.
So this will be red too. Oh.
Yeah.
So what instruments are there on New Horizons that we can...
There are spectrographs there with a very significant resolution, a pretty precise resolution of the order of 1 part in 1,000 of the wavelength. So they can actually map the wavelength distribution rather precisely, and therefore hopefully be able to spot the surface materials to some extent.
They know exactly what's in there.
You need geologists and chemists to actually understand that properly. But that is what they can measure with the spectrometers, together with the colorimetry. They have also a color picture camera that makes color picture cameras up to this resolution of about a bit better than 100 meters, in fact, as the smallest pixels. And that will give us the surface structure and also the crateredness and see whether there's boulders on there, like we saw also on this Rosetta comet.
Yeah, there were boulders on Rosetta as well. Yeah, that was super funny. Yeah, because you don't expect it to have like pebbles laying around.
Yeah, let's push them, you know.
Yeah, exactly.
Why isn't there nobody around to push them?
That is not
or build
trivial.
something out of them.
Yeah, exactly.
To get these boulders up there, mind you, it's worth your while to realize that the velocity of escape is such that if you just push a bit of dust away, it actually leaves.
Fly off.
It flies off. The velocity of escape is of the order of centimeters per.
Kids would have so much fun on Ultima Thule.
Yeah. Well, or if they would start jumping up and down, they would just jump up but never come down.
You would easily jump off. You would very easily
Yeah.
jump off. In fact, the Rosetta softlander bounced back.
Philae, yeah.
Philae almost, well, not quite. It bounced back with a velocity bouncing up again of about a foot per second, which is a quarter of the velocity of escape. There. It came down with a meter per second, which is 85% of the velocity of escape.
Yeah, so
that's the way it landed.
a quarter. So it could have almost
Well,
not made
I
it.
would have not have done that, but I mean, that's the sort of velocities we're talking of. So it's very easy. If you would be there and you would jump up, you would depart completely.
Yeah.
I looked a couple of things up back home. I did some homework, and I forgot to look it up on Ultima Thule, but I did look up the escape velocity at Bennu, the asteroid that we may talk about later on in this podcast.
We will, Yuri.
It is 250 meters across, and the escape velocity is 20 centimeters a second.
Exactly.
So that's for a body that is about 8 times bigger in. Yeah, what you're doing now.
Yeah, so you're
would send
slowly
you off to
walking.
space.
Yeah, slowly walking through a room would send you off into space.
Exactly.
That's not good.
Just
you need a
getting
cable
up,
to
just getting up
to
out of
tether
your
yourself.
chair would send you into space. Okay, and that's for a much larger body than Ultima Thule is.
Yeah.
So I want to go to the Brian May song.
Oh yeah,
I just saw I saw a picture of Brian May and it says astrophysicist, rock star. It's like that's a pretty good title to have.
He has the hairdo of a rock star. It's still the 70s look that he has, and he's at the New Horizons team. And they call him a contributing scientist.
Yeah,
what he really does isn't clear to me. I don't think he does a lot of very significant things. But he did write a song about New Horizons, and
he was part of the imaging team as well, right? For around Pluto, I think he was just a staff scientist. But he's Brian May.
Yeah,
so
That's the name that counts.
that counts for something.
He did some image editing to turn Pluto's photographs into photographs with depth.
Okay.
I can't think of the right. Let me think about this, and I'll play the song and look it up for you. Hang on.
They will find a job for him for this thing, but until then, he has written this song.
Hang on. Starts with the countdown as well.
Oh, nice.
8, 7, 6, 5, 4, 3, 2. We have liftoff of NASA's New Horizons spacecraft.
The revelations of New Horizons may help us to understand better how our solar system was formed.
Stephen Hawking speaking.
New horizons to explore. New horizons no one's ever seen before. Limitless wonders in a never-ending sky. We may never reach them. That's why we have to try. New horizons to take our breath
Well, that ought to give you an idea.
I like it.
You do?
Yeah, I do like it. Yeah, it channels Queen. I mean, obviously, and it's I don't know. At least, well, if you have him on the team, then you need to do something with it. So
Yeah.
yeah, I think it's great. Why
I
not?
happen to know that Rudolf has a different opinion, right, Rudolf?
But that's of course I've a bit of a taste for monoculture, which is dated about a century or more before that.
You're a classical music buff,
Yes.
right?
Yeah. No, I love it. Whenever you can merge popular culture and space exploration, I love it.
Yeah.
Just whatever gets the message across. So,
Okay.
It depends on who you're talking to. That's why I suggested to Herbert, does it really make much difference? There's a thing that's flying out away from the sun into the Milky Way. It's going to travel there. And if it ever gets discovered by some other intelligence, then it doesn't matter whether we have the
I'm not sure
the
they are
music
sending.
of
I'm not sure they're sending this song into space. It's not like it's on the disc on board the New Horizons.
If only we would have
spacecraft.
played this podcast on analog radio, then I would have beamed it out into space.
Yeah.
You know, but no, we're digital.
We made sure that doesn't happen.
We're keeping it on Earth.
Okay.
But I agree with you, Thijs, that it's PR-wise a good decision to have a song like this, but I don't like the song.
No, that's okay.
I mean, it's very simplistic.
New Horizons.
Yeah, it's. Yuri, tell me, what's your idea about this?
It's very Queen-like. I'm not the biggest fan of rock music, so I don't think I'm the best person to ask this. But
it started off with almost like an electronic.
yeah, so that's what got my blood flowing. And then, maybe I just had another question about New Horizons, because what's the future for New Horizons right now that it passed the Kuiper Belt?
Yeah, what's
object?
next?
Yeah,
Good idea.
It's going to be busy sending data down for the next year. But it's on its way. It's also passing by a few other objects. It's not going to be maneuvered sufficiently close to do detailed observations again from there. But it looks at it from another angle than we can ever look at, because we live from those objects seen. We live very, very close to the sun. So we always have the sun in our back and the light comes back here. They can now observe other objects with a different phase angle, as we say, the direction at which the reflected light leaves the object, and that therefore tells us something about the surface structure. And hopefully we can even get some more from the colorimetry from relatively nearby. These objects are almost invisible from here. Only the very biggest telescopes or things like the Hubble can, with a lot of time, just barely see these things, but we know now enough of them to find a few that can be observed from.
And there's going to be another flyby, right?
Sort of, not so nearby that you can.
Not like this one.
No, not like this one.
But it has enough fuel to.
It has fuel for the next 20 odd years.
Yes, awesome.
And it has also enough fuel for power. It gets power from a nuclear power plant, and therefore it has plenty power for.
Just like Voyager, like the
Exactly.
plutonium,
That's the
plutonium
trick, yeah.
thing. Oh, going. Okay, so it's so it has a plutonium reactor on board. Yeah.
Will the probe also leave the heliosphere in due time?
In due time, but that is a long time away. It's going only 40 astronomical units in 12 years. And it needs to go to 140 almost. So
Okay, and that's where Voyager 2 is right
Exactly.
now.
Yeah.
Because it left the heliosphere on the 5th of November.
Right.
5th of November.
Yeah.
Oh, so we didn't hear about it until last month.
No, I think
not
you
sure.
could.
I heard it. I remember because I was going to interview the people from the Voyager team who will be on the podcast one day, but it didn't happen a month ago.
Yeah.
And then I remember because I was so sad because the next day, right after they canceled the interview, right the next day, it was suddenly all over the news that Voyager 2 had left the heliosphere. And
I seem to remember it was the 5th of November, but
then maybe it was the 5th of December.
Why don't you do some fact checking there?
Fact checking. Yes.
Okay.
But so, which one's faster, New Horizons or Voyager? Voyager is faster.
Voyager is there already.
Yeah, of course, but it was sent out earlier.
In terms
Yeah,
of
but,
speed.
Which one's faster?
I think they're similar velocities. In fact, Voyager 1 was launched slightly after Voyager 2.
Yeah, strange. Yeah.
Well, that just happened because of a hold-up, of course, at the time. And but it was thereafter it was flying slightly faster, and therefore Voyager 2, being the first to be launched, flew slightly slower and was overtaken by Voyager 1. Voyager 1 was there 1.5 years ago.
Yeah, of course. Yeah, it was a big moment. Yeah, and
At that time we didn't know where it would be. We were looking for it for at least 5 years already. It might have been another 5 years. So we don't quite precisely know where that is. Now we know a lot better because of the plasma measurements being made in situ, the property of the free-flying particles in the bow wave of the sun in the interstellar matter. That has a steep transition at that location, and therefore flying right through that. You can see that.
Yeah. So fact check is here. You were absolutely right. November 5th is when it happened, and so it was put out there in the media on December
Maybe
9th
the information took
so they just
weeks to get back to her.
Well, how far is it now? It's about 22 light hours away, I think, right? Voyager 1 was, Voyager 2, I'm not sure.
It's like 150 astronomical units? Is that
Not
right?
quite. It's about 115, I thought.
115, okay.
So it happened on November 5th, and then takes a day, and then I guess it takes them like a month to analyze the data and put it out
could
there.
Be it.
Yeah,
It's about 4 times as far away. No, it's 150. It's about 4 times as far away, almost 4 times far
As
away.
New Horizons is now.
As New Horizons is now. And therefore, their messages take almost a day, one-way trip.
Yeah. And like we said, space travel is it's slow. Space exploration, it just takes a while.
You have to be patient. Okay. So we have the Voyager 2 in the interstellar, out of the heliosphere. We have Voyager 1, which has left the heliosphere even before that.
That's right.
How about the Pioneers 1 and 2? Where are they now?
I think they're just in the solar system. They didn't fly out of the solar system, as far as I recall.
Okay, they don't have escape velocity.
No.
Oh, I see. So they're
Really? So they're going to come back?
No, they're circling the
Well,
sun.
they-
Circling the sun. Yeah, that's what I mean.
they have a
not
slingshot.
back to Earth. No.
No,
yeah.
they can't because they've had slingshots by Jupiter and Saturn.
Yeah.
And they're probably in some different orbit now.
There's in some sort of orbit.
As far as I recall, they were not on their way out.
There's something to marvel because I think Pioneer 1 and 2 don't work anymore, do they?
That's right.
Okay, and the Voyagers do.
Yeah.
No, because they have this. They both have this nuclear power plant.
Yeah.
This, plutonium.
And how old are they now? About 40 years or something?
Yeah, that's right.
That's incredible.
Yeah, and I keep on reading that the Voyagers will probably until the mid-20s they will probably be on, and they will be shutting off like certain instruments one by one. So I think we have about 10 more years
I
of
would
Voyager
hope
fun.
NASA has been doing that a lot better than we have in the Netherlands. NASA has not ever turned off a successful live satellite. It's always, again, a fight to get the funding for the next period. But
they
if
always
the
manage.
They always manage, as long as this thing is working properly. And the Voyagers are still generating very worthwhile data, so it's rather unlikely that it will be killed. We once turned off ANS because it had fulfilled its predetermined mission.
The Astronomical Netherlands satellite.
That's correct.
Yeah.
I'm here.
That
my
was not
fir-
a particularly good move. And I think we're the only ones to have done a thing like that.
I'm down to my third fact check here.
Yeah.
Yes, we need to hire somebody.
You're doing a very good job.
Yes, but this is some Wikipedia facts. So here we go. If left undisturbed, Pioneer 10 and its sister craft Pioneer 11 will join the 2 Voyager spacecraft and New Horizons in leaving the solar system to wander the interstellar medium and hopefully be picked up by aliens because it also has those plaques.
Yes, but they're
like
not
Voyager.
sending back data.
Yeah.
They're not sending back data.
They've been switched off.
No,
Or
but they do have the
they
plaque
died.
with the man and woman and and
Yeah, they have
Not
to
sure.
Pioneer
Yeah.
Golden Plaque.
yeah, the Pioneer
Yeah.
Golden Plaque.
Yeah. Which are for sale on Earth, by the way.
Oh,
Yeah. There's
You
a
can
company.
also listen to the music and the sounds that were sent.
Johnny
on
Be
that
Good
plaque.
and all that stuff.
Okay,
Yeah.
we'll try and have the website in the show notes. See if we can. You can help us find that. Now
We have some time left to talk about the asteroid missions with
we should
Yuri.
do that
Yes,
because
definitely.
that was
Please.
on the New Year's Day's events list as well. The fact that NASA put their OSIRIS-REx spacecraft in an orbit around Bennu.
Yeah, they were quite busy.
In fact, that
Yeah,
I
happened
missed
in
all
December
of this.
already.
What happened?
Starting the orbit happened already the 18th, I think, in December.
So what did they do on New Year's Day? Did they change the orbit? I mean, it was the closest approach ever. I seem to remember.
They're going to come closer and closer. They're going to
Yeah.
fly orbiting this thing by gravity
Yeah.
of a thing that has an escape velocity of only, as we have just discussed, a foot per second or something like that.
Right.
Even slightly less. They're orbiting this thing at an altitude of 1.75 kilometer.
That's right. I read that. It's
Which
so.
is
But what
It's
is
so
Bennu?
close.
Yuri, what is Bennu?
Bennu is a very small asteroid. It's what we call a C-type carbonaceous asteroid. So it contains a lot of carbon composites. So it's basically like a building block of the early universe. So it might
Early
contain
solar system.
Yeah, the early solar system. Yeah. So it might contain some building blocks like amino acids or maybe even water. That is what we are made of. So finding out what these type of asteroids really are could help us with understanding where we come from, how this solar system was formed, those important questions.
And where is this thing? Where? In the solar system.
In our backyard.
In our
of
backyard
course.
somewhere. Yeah.
Yeah, but it's. I suppose it's between Mars and Jupiter somewhere.
Okay. Yeah.
It is. It is.
It's about a bit less than 2 astronomical unit semi-major
Okay.
astronomical unit semi-major axis for the orbit.
Right.
The period is 2 and a bit years.
And it's gonna return a sample.
It is.
Yes.
So that's the most exciting
Super
part of
cool.
this mission.
Like the Japanese are too, by the way.
Yeah.
They landed already.
So it's going to stay at Bennu for quite a while. So it just entered orbit, and then it's going to stay there for more than a year, up until the July 2020. And then it's going to slowly reach the asteroid and deploy a bit of like a vacuum cleaner. It's going to fire a bit of cold nitrogen gas, and then it's going to collect all the dust that's being thrown around, and it's just a bit like a vacuum cleaner, and it's going to suck up all the dust, into a capsule, and then I think a year later, in March 2021, it's going to fire away the capsule back to Earth, and then they're going to collect the dust from the capsule, hoping to find out what the asteroid is made of, finally get their hands on real asteroid dust.
But will something land on Earth, or will they just throw some package into the atmosphere and try and find it back?
No, it is a controlled landing. So they're going to fire a capsule back to Earth. It's going to hit the atmosphere at quite a big speed. So it's about 44,000 kilometers per hour. That's quite an astonishing speed.
Which is standard orbital velocity. Yeah.
Wow. Yeah.
So
A
it's
bit
very-
faster than that. It is because it comes not from orbiting the Earth, but it comes from being
Outer space.
free from the Earth beyond its velocity of escape.
Yeah,
So it's slightly above the velocity of escape, and it arrives at the Earth just like that. But the capsule is capable of making it to the ground.
Yeah, and I think it's going to land somewhere in Utah. So it is a controlled landing. So they don't have to search the whole planet for it. No.
And Utah is pretty
actually
empty,
can-
so that's nice.
They can aim that precisely that they can decide to have it land in Utah.
Fortunately, we can do that. Otherwise, we couldn't have flown New Horizons where it is
true.
right
Yeah.
now either.
And I think they already have,
Well,
they have some experience with
I'm still
this.
surprised because if some satellite falls back to Earth, they have trouble even a day in advance of predicting where it will hit the ground.
Because that is determined by the upper layers of the atmosphere and the friction there. This thing is orbiting in an increasing friction and coming down, down, down. And the density of the upper atmosphere is not sufficiently precisely mapped, and therefore, if it then happens autonomously, it just happens.
Yeah, and it's also because
Whereas
of the,
here, if you make a targeted slowdown of the object in such a way that the trajectory up till the top of the atmosphere is predefined, and you can also define what happens thereafter.
Yeah, and I think they did the same about 20 years ago with the Stardust capsule. So they also have some experience with landing a small capsule like this.
They did with astronauts too, on their way from the moon. Apollo 13 is by far the most conspicuous and very, very important example.
Oh yeah.
We couldn't maneuver then, hardly. The poor problem was that the command module was so dangerous, it might just explode if you would run any engine on that thing. And so they were using the lunar module as their life-saving boat, you might say. And they were flying on the engines of the lunar module. And they had made the mid-course maneuvers at the moon, and they decided on the way back whether they needed to even correct it. The idea was it would have to be corrected. They actually landed the astronauts almost a kilometer per second too fast by coming a bit too steeply in. And they have decided that that was safer than to yet make another maneuver. And that way we knew ahead of time where they would land. And so
Yeah. I remember the space journalists back then explaining that they could enter the atmosphere at too steep an angle,
yeah, exactly,
and get burnt up, or they could enter the atmosphere at a too shallow an angle
and
get bounced back to space.
I've seen the movie.
That's okay.
We all have.
That is exactly.
I got this from real life.
Tom Hanks really did this, right? Tom Hanks really went to the moon. It's crazy.
It's so impressive.
But it actually happened.
Yeah,
I remember it happening, and it was
Must have been so
very,
scary.
very fascinating and
Yeah.
scary.
It was, yeah.
But it was extremely fascinating that management in those days could be so much on top of what they were doing, even when things went wrong.
And be so creative in finding
I
solutions.
wish we
and
could
everything.
maintain that quality of management.
Yeah.
Okay, let's hope so.
And before we go, I want to hear something about the Japanese mission.
That's right,
Yes.
because-
What's going on with the Japanese mission?
That's even more interesting, maybe, than the.
Yeah, it is
American
my
mission.
favorite one at the moment. So the Japanese are also exploring asteroids. And they're exploring Ryugu, which is a comparable kind of asteroid. It's also a C-type asteroid. If you look at the pictures, it almost looks the same as
They're almost identical.
Bennu, and it's almost identical.
Escape
It's a-
velocity 38 centimeters a second.
Yeah, it's a bit larger than Bennu, but they're also there to gather some samples of the asteroid. So they're going to do it in a bit different manner. They also have a vacuum, so they're going to suck up some dust as well. But they're also interested in seeing what lies below the surface of the asteroid. So they're going to fire a projectile, and that's going to create a new crater on the asteroid. And then they're going to suck up some dust, which is below the surface of the asteroid. So they're trying to find out what the building blocks of that asteroid really are. And I think that's makes it a bit more interesting than OSIRIS-REx.
They got these hopping rovers.
And they got rovers.
Exactly.
So we have the first images from the surface of an asteroid. And I think we'll post some pics in the show notes.
Oh, yeah.
Just to show them, because they landed some of the first rovers back in
two
September.
Yeah.
And they beamed back some interesting imagery from the surface. And it also contained boulders, just like the Rosetta probe beamed back.
Correct.
But they're also going to fire away one more rover in July, and it's a bit bigger than the ones that they fired away in September, and that's going to collect more imagery from the surface of the asteroid. But basically, it's the same kind of mission as OSIRIS-REx, collecting stuff from the surface of an asteroid and bringing it back to Earth for further analysis.
Yeah.
So the Japanese are into this whole rover business.
Apparently, yeah.
Wow.
It's Hayabusa too, so it's basically the second one.
Yeah.
They tried it in 2003 with Hayabusa 1, of course. It encountered quite a lot of problems, so they were only able to gather a few specks of dust from asteroid Itokawa. And now they're trying it again with a newer, bigger, better, and better.
I remember thinking when this was in the news, when they arrived at this asteroid and released their rovers, I remember thinking, if NASA did this, it would be all over the news. It would be all over the front pages, but it wasn't. Can you explain to me why Japanese space exploration gets so much less publicity than the Americans?
Well, I think it's mainly because the Japanese themselves don't spend a lot of time on PR. They're very science-driven, I think. You see that they launch quite a lot of missions, quite a lot of interesting missions, but they hardly spend any time on PR. At least to the outside world, they don't spend a lot of time on PR. I'm not sure why. They do
Americans just really know how to sell something well.
Yeah, and I think the Japanese, the Japanese are very
beat
interested.
ESA also by a long shot.
Yeah,
Japanese know how to sell cars.
yeah. But the ESA, indeed, it's the same. ESA, I also find lacking in their PR.
Yeah,
they can do so much more.
JAXA, the Japanese Space Exploration Agency, is more interested in getting the science out of there than really selling their science, really selling what they achieve.
And celebrating because it's wonderful and awesome. So why not celebrate for the whole world to show?
Yeah, because I don't think a lot of people know about Hayabusa, but it is a very cool mission. I mean, it's cooler than OSIRIS-REx because it contains rovers. You want rovers, right?
A rover on Asteroid.
Yeah. And you follow not just Japanese but Asian space flight very closely.
Yeah.
So what's happening there? Is that something big?
Well, the Chinese are onto something. I think tomorrow. We're not sure entirely because the whole Chinese spaceflight program is very secretive. They hardly release any information. But I think tomorrow, so that's January the 3rd, they'll land on the far side of the moon. And
of course. Is that tomorrow?
Chang'e 4.
And that is with a
so cool.
Dutch instrument.
Yeah, they launched a separate satellite last year to the far side of the moon, and it's a communication satellite because, it's the far side of the moon, so you never see the Earth from that side. So you need another satellite to communicate. You need a rear mirror to beam back any data, to beam back any pictures from the far side of the moon. So tomorrow they'll land a rover. A bit like the Chang'e 3 rover that they launched, I think, in 2014. It's already quite a long time ago, to the near side of the moon. And tomorrow they'll land in the Von Karman crater, which is part of a very interesting part of the moon. It's the South Polar Aitken Basin. It's a big area that also contains a lot of information about how the moon was actually formed.
Okay,
so that's
I see Rudolf nodding, so that's a good point.
What sort of instrument is on there, you said?
The Dutch instrument that's there is just a radio receiver to do very low frequency radio interferometry together with another receiver on the Earth or in orbit later on, because we can go to frequencies that don't make it through the ionosphere. Mm-hmm. And it's the first time we have an observation from the back of the moon where we do not have all the other radio transmitters generating all this noise.
Yeah.
So that's a colossal leap in instrumentation for radio astronomy.
Giant leap for mankind.
On the other side of the moon.
Yeah.
Good.
And China-wise, if everything goes well, they'll launch Chang'e 5 later this year. It's a bit dependent on their rockets because they had a bit of a problem 2 years ago with their newest kind of rockets. It blew up. And they're going to launch Chang'e 5, and that's a sample return mission. So they're going to return some stuff from the moon, some dust.
For the first time
rocks.
in decades.
It's in decades. I mean, the Russians did it in the 70s with their lunar missions, but it's quite a long time since anything came back from the moon back to the Earth. So China's really working on it, and it's really interesting to see what they're doing. Also, at the end of this month or the beginning of February, India will launch a rover to the moon.
Wow.
The moon is where it's at right now. Yeah, we need to go to the moon.
Yeah, there's so much going on in the moon.
Yeah.
And interesting one is also in February, the first commercial mission to the moon will launch. It's a mission by an Israeli company, Space IL, and they're going to launch on a Falcon 9 rocket, and it's going to be the first commercial lunar lander.
Oh, yeah.
Wow.
Cool. Well, we got so much to talk about.
Yeah, I think the moon is a completely another
What's the
subject.
business model there?
Okay.
Well, we'll do a show.
That question
let's do a show on that.
Hey,
that's great.
You're the first time here. Everybody's the first time here, but you'll be following Asian space flight for us,
Yes.
and we'll
So
be seeing
cool.
you back many times, I'm sure.
Yeah.
Great. Yeah, there's so much happening in that side of the world.
Yeah,
so.
especially and I don't speak Chinese. I don't speak Japanese, and it's great if you can follow it for us. Then
You don't
we'll
speak Chinese or Japanese, do you? Or do you?
No.
Oh, you were just really good at pronouncing that name.
But you are following blogs and fora or whatever what have you on the web.
Yeah, but it's especially for Chinese spaceflight, it's very hard to get a grip on what they're doing. So it'll be interesting to see how everything plays out in 2019.
We'll happily leave that to you.
Yeah, nice.
We have contacts with the Chinese about space business through TNO, of course. But,
okay, great. We'll ask them too. Yeah. And I think this is about the end of our show. We talked about everything. Thank you so much to both of you, Rudolf le Poole and Yuri.
Thank you.
Thank you very much. We will see you together. Herbert,
Nice.
thank you so much. I just want to quickly tell who we're going to meet next week. This is Ingeloes ten Katen, who knows everything about Mars and the hunt for life, and she's great and amazing. So really looking forward to that conversation.
Okay, we're seeing everybody back next week. Thank you very much. This has been the first episode of Space Cowboys. Thank you. Bye.
Thank you all.